This is a view of the whole product. It consists of the Raspberry Pi, a microphone, an analog to digital converter, and the stethoscope head. We're going to demonstrate how our digital stethoscope can work.
Abel is just loading up the file right now.
So I just put the stethoscope to my chest, and then the GUI should load up now. As you can see here, we've got a live plot of the heart data, which is useful for doctors to make their own diagnosis and analysis.
We also have a live output of the BPM based on real-time data with a weighted decay function, which means recent heartbeats are more valued than older heartbeats.
This is the AI section, and it's collected the data and is currently processing it.
This section is used by the doctors to input data such as their name, sex, age, and this space is for the doctor notes such as patient history and any medication they may be taking right now. This allows doctors to build a patient history over a long time with this software.
Here the AI has decided on its diagnosis.
It's given a diagnosis of normal with a confidence of 94.8%. This is useful for whether or not the doctor should trust the diagnosis. It's also given advice from the NHS on how to maintain a healthy heart. This could be specific to the diagnosis.
Here is a log of the output of the training script for our neural network. Here you can see we're able to achieve an accuracy of over 98%.
Now we're going to test our model on various data classes. So first we're going to test it on normal data from our stethoscope. So this should output a diagnosis of 0, which corresponds to normal. 1 would correspond to extrasystole or extra heart sound, and 2 would correspond to murmur. It will also output the confidence in this diagnosis. As you can see here, it's given a diagnosis of 0, which corresponds to normal, and a confidence of 100%. This is obviously rounded. Now we're going to test it on a normal heart sound from our dataset. So this is once again given a diagnosis of 0, which corresponds to normal, and a confidence of 100%. Now we're going to test it on an extrasystole heart sound from our dataset. So as you can see here, we have a diagnosis of 1, which corresponds to extrasystole, and we have a confidence in this diagnosis of 91.6%. Finally, we'll test it on murmur data from our dataset. So this should give us a diagnosis of 2. So here we have our diagnosis of 2, which corresponds to murmur, and a confidence in this diagnosis of 99.2%.